Today we're going to be talking about solving equations with variables on both sides. And so let's start with this first problem. We have 4b plus 2 equals 3b. So basically what your goal is to get all variables on the same side. So that's something you will probably want to write down or make note of somewhere. Okay, so we want to get all the b's onto the same side. So for instance, if I draw a line through my equal sign, let's say I decide I want to move my 4b. So I'm going to subtract 4b from each side. And the 4b's on the left cancel, and I have 2 equals, well, 3b minus 4b gives me negative 1b. I want to get b alone now, so I'm going to divide each side by negative 1. And so the negative 1's on the right cancel. And on the right side, I just have b. And 2 divided by negative 1 gives you negative 2. Now, if you want to check this, you're just going to take that negative 2 and plug it right back into the original problem. So you look at the original problem, 4b plus 2 equals 3b. So we're going to have 4 times negative 2 plus 2. We want to know, does that equal 3 times negative 2? Let's think about it. 4 times negative 2 gives you negative 8. Negative 8 plus 2 gives you negative 6. And 3 times negative 2 on the other side, sure enough, does give you negative 6. So this thing checks out. We're not going to check every problem, but I just wanted to show you how to do one of them. Okay. And I'll put this negative back in where it belongs. Okay, so let's do the next problem. Again, we have 0.5 plus 0.3y equals 0.7y minus 0.3. We want all the variables on the same side. It doesn't matter which side you choose. Let's say I decide to move the 0.3y. So I'm going to subtract 0.3y from each side. I don't know why my pen does this. Okay, so 0.3y's, they cancel, so we have 0.5 equals 0.7 minus 0.3 gives you 0.4y minus 0.3. So now we want to get y alone, so we're going to have to add 0.3 to each side. So on the right-hand side, the 0.3's cancel. 0.5 plus 0.3 gives you 0.8. So we need to get y alone. And 0.4 is multiplying the y, so we're going to do the opposite and divide each side by 0.4. And so on the right-hand side, the 0.4's cancel. And we have 0.8 divided by 0.4, and that gives us 2. So y is equal to 2. Let's look at the next problem. We have 1/2 times in parentheses b plus 6 equals 3/2 b minus 1. Don't be intimidated by the fractions. They're fine. So let's go ahead and distribute. We have 1/2 times b gives you 1/2 b. 1/2 of 6 gives you 3. And on the right-hand side, we have 3/2 b minus 1. Let's say we want to get the b's all on one side, and let's say we want to move the 3/2 b. So that means we're going to have to subtract 3/2 b from each side. It doesn't matter, really, which one you move, just as long as you get them all on one side. 3/2 b's cancel. And if you have 1/2 minus 3/2, that just basically, 1/2 minus 3/2, that gives you 1 whole, as a negative, I should say, a negative 1b. All right, so we have negative 1b plus 3. And on the right hand side, because think of it this way, if you have 1 minus 3, that gives you negative 2, and negative 2 over 2 gives you negative 1, and this is a b next to it. So we have negative 1b plus 3 equals negative 1. Want to get b alone again, so you subtract 3 from each side. So 3's on the left cancel, and we have negative 1b equals negative 1 minus 3 is negative 4. And I'm just going to bring this up to the side here, so we've got room. So we have negative 1b equals negative 4, so we divide each side by negative 1, because we want to get b alone. The negative 1's on the left cancel, so I have b equals positive 4. Let's continue with this next problem here. First of all, before we do anything, we need to combine like terms and get rid of any parentheses we have. So 3x on the left-hand side doesn't have a like term to go with it, but 15 minus 9, those are like terms, and 15 minus 9 gives you 6. On the right-hand side, we have 2 times in parentheses x plus 2, so we're going to distribute. 2 times x gives you 2x. 2 times 2 gives you positive 4. So now we want to get all the x's onto one side. We're ready to start solving. Doesn't matter which side you move them to. I'm going to move my 2x. So I'm going to subtract 2x from each side. The x's on the right cancel, and 3x minus 2x gives you just plain old x. You can put 1x if you want. So we have x plus 6 equals 4. You want to get x alone, so we need to subtract 6 from each side. 6's cancel. We end up with x equals negative 2. So let's go on to the next problem. John and Sarah are planting tulip bulbs. John has planted 60 bulbs and is planting at a rate of 44 bulbs per hour. Sarah has planted 96 bulbs and is planting at a rate of 32 bulbs per hour. In how many hours will John and Sarah have planted the same number of bulbs? How many bulbs will that be? So let's start. Let's choose a variable. Let's say x will stand for your number of hours that they are planting. And you can choose any variable you want. You can choose h if you'd like. John, he's already planted 60 bulbs, and he's planting at a rate of 44 bulbs per hour. So if you add to it 44 times the number of hours he's planting, so in other words 44x, that will tell you how many bulbs he's planted. Sarah, on the other hand, is planting at a rate of 32 bulbs. I'm sorry, she's already planted 96 bulbs. And now she's planting at a rate of 32 bulbs per hour. So if you add to that 32 times the number of hours she's planted, that'll tell you how many bulbs Sarah has planted. And we want to know in how many hours will they have planted the same number of bulbs. So if we set those two expressions equal to each other, we have an equation to solve now. So let's go ahead and do that. Let's get all the variables on each side. So I'm going to move the 32x. So let's say I subtract 32x from each side. 32's cancel on the right. So I've got 60 plus, well, 44x minus 32x gives you 12x. And I want to now get x alone, so I'm going to have to subtract 60 from each side. So the 60's on the left cancel, and I have 12x equals 36. Now we want to get x alone, so we're going to divide each side by 12. And 30 on the left, the 12's cancel, and on the right, 36 divided by 12 gives you 3. So in 3 hours, they will have planted the same number of bulbs. Now, since they both planted the same number of bulbs, it asks us how many bulbs will that be. So you could take, since they're going to be the same, you could take either expression for John or Sarah and plug in that 3 hours. So like, for instance, if you take, say, this expression, 60 plus 44x, you're going to plug in x equals 3. So you're going to say 60 plus 44 times 3. And we need to do that multiplication first. And 44 times 3 gives us 132. If we add to that the 60, we get 192 bulbs. There's a 1 there. We'll put that right in front. There we go. 192 bulbs. Okay, so now let's go on to the next problem. Brad and Jared both sell sport performance sunglasses in the mall, but for 2 different companies. Brad earns $125 plus 15% of his sales each week. Jared earns $130 plus 11% of his sales each week. How much will they need to sell each week for their earnings to be equal? So let's set up some expressions here. One for Brad, one for Jared. And let's say that X stands for the amount of their sales, because we want to know when those amounts would be the same. I don't know why it's doing that. There, now that's fixed. So Brad earns $125 before he sells anything, and then plus he gets 15% of his sales. Well, 15% we write as 0.15, so that'd be 0.15 times X, so 15% of the amount that he sells. Jared, he earns $130 plus 0.11, because 0.11 stands for 11% of the amount that he sells. So let's go ahead and figure this out. Now we have an equation to solve, so we're going to subtract 125 from each side. And we end up with 0.15x equals 5 plus 0.11x. Let's subtract 0.11x from each side. You notice I did not move the variable first, and it really doesn't matter whether you move that first or not if you've got other like terms that you can combine together. So the 0.11x's cancel on the right hand side, and we end up with 0.04x equals 5. We need to divide each side by 0.04, so they cancel out, and we have x equals 125, and we're talking dollars here. So if they each sell $125 worth of merchandise each week, their earnings will be the same. Let's go to the next page. The 2 figures shown below have the same perimeter. Find the perimeter of each figure. Okay, so first of all, the perimeter is found by adding up the lengths of the sides. So if I took all these expressions on the triangle and added them together, they should be equal to the expression for the perimeter of this other figure. Now, I'm running out of room here, so you know what I'm going to do? I'm going to do the perimeter of the triangle and actually combine my like terms and get an expression for that first, and then I'll write out the rest of it. I'm underlining my like terms that have an x in it. So I have 3x plus 3x plus 1x. That gives me 7x. Then my other like terms, 7, 7, and negative 3. Well, 7 and 7 is 14. 14 minus 3 is 11. So The expression for the perimeter of the triangle is 7x minus 11. On the right-hand side, let's add all of these other expressions together. So we've got 2x plus 2. We've actually got 2 of those, so let's just put a 2 in front. Okay, because we're saying both sides, opposite sides are 2x plus 2. And then we want to add to it the 2x minus 1, which is on opposite sides, so we could say 2 times 2x minus 1. Getting a little fancy here with that. Now let's go ahead and distribute. So 2 times 2x gives you 4x. 2 times 2 is 4. Now let's do the next one. 2 times 2x is 4x. 2 times negative 1 is negative 2. So now let's combine our like terms. We have 4x and 4x, which gives us 8x. And 4 and negative 2 gives us positive 2. Now, they said, so we've got the perimeter of each figure. Here's your, this is a parallelogram here. Just make the symbol for a parallelogram. And it says the perimeter is supposed to be the same. So we can take those two expressions for the perimeter and set them equal to each other. So let's do that. And now let's solve for x. So get all the variables on the same side. I'm going to subtract 7x from each side. I have negative 11 equals x plus 2. So now we want to get x alone, so we're going to subtract 2 from each side. And we have x equals negative 13. Now, it says they want us to find the perimeter of each figure. Well, right off, we notice that there's a little bit of a problem here because what's happened is we're getting a negative here, and if I'm going to plug a negative into this expression, or either one, I'm going to end up with a negative number for my answer. So we need to go back and take a look and see was there a mistake made along the way, and I can see one right off. Here we have, when we added, I'm pointing up here now, 7, 7, and negative 3 together. That should have given you a positive 11. So that means we're going to change this into a positive going down through. It's good for you to see that because a lot of people do make mistakes, and I'm not immune to it either. So how does that change our answer? If we have 11 minus 2, that gives us 9. So if x is 9, let's go back and plug our number into either of these expressions. We should get the same answer for either one. So if we have 7x plus 11, we're going to have 7 times 9 plus 11. 7 times 9 is 63. And 63 plus 11 gives you 74. Let's see if we do get the same answer for the expression for the parallelogram. We have 8x plus 2. So 8 times 9 plus 2. 8 times 9 is 72, and 72 plus 2 gives you 74. Yes, and so both of those answers are the same. So the perimeter of each figure would be 74 units. Okay, so thank you for joining me today.